Effects of parameter k on y equals tan k theta. We shall now investigate the effect of parameter k on the tangent function y equals tan k theta. Consider the tan function y equals a tan k theta plus q, where a equals 1, q equals 0, and k equals 1. It becomes the tan function y equals tan theta, which we saw earlier. Consider the tan function where k equals 2. The function becomes y equals tan 2 theta. We can calculate the y values of this function and plot the graph on the same set of axes. Observe that the shape of the graph of y equals tan 2 theta is the same as that of the graph of y equals tan theta. However, the period of the function has changed. Period of the function y equals tan 2 theta is 90 degrees, which is half of the period of the function y equals tan theta. Hence we can say that changing the parameter k affects the period of the function. Now let us consider an example when k is less than 1, say 1 over 2. The function becomes y equals tan theta over 2. We can calculate the y values and plot the graph on the same set of axes. Again, the shape of the graph has not changed. However, the period of the function has changed. Observe that the period of the function y equals tan theta over 2 has in fact doubled when compared to the period of the function y equals tan theta. Now let us consider a couple of examples where k is less than 0. Observe that the graph of y equals tan negative 2 theta is the reflection of the graph of y equals tan 2 theta about the y-axis. When k is negative 2, the period has reduced by half. Let us summarize our findings on the effect of parameter k on the tangent function. For k greater than 1, the period of the tangent function decreases. For 0 less than k less than 1, the period of the tangent function increases. For negative 1 less than k less than 0, the graph is reflected about the y-axis, and the period of the function increases. For k less than negative 1, the graph is reflected about the y-axis, and the period of the function decreases. Note that we can also calculate the period of the function algebraically. We simply divide the period of the basic tangent function by the magnitude of k, that is, ignoring the sign. Period of the function tan k theta equals 360 degrees over magnitude of k. Period of the basic tangent function is 360 degrees.
Need more help? Subscribe to our channel. Can't wait that long? Ask Maskly to help you and let the math finally start mathing.